The topic of this video is solving nonlinear systems of equations by substitution or elimination. Let's look at a problem. Alright, our top equation is y squared plus 49y plus x squared minus 5x minus 50 equals 0. Our bottom equation is y squared plus 49 plus a fraction whose numerator is 5x minus 50 and whose denominator is y equals 0. Okay, great. So, first decision, substitution or elimination. Let's go through the 3 steps of making that decision. First, clear fractions. We do have a fraction in our second equation, and the way we're going to clear that fraction is by multiplying both sides of the equation by the least common denominator. Well, only one term has a fraction, and that would be this one right here. Its denominator is y. So if we multiply both sides by y, then that should clear away this fraction. On the left, we'll have to use the distributive property. On the right, we will simply multiply. All right, so here we go. Y times y, y squared, plus y times 49, 49y, plus. When this y gets multiplied by this fraction, this y, which we can write as y over 1, will cancel this y down here in the denominator, leaving us with the numerator 5x minus 50 times 1 and divided by 1. Well, anything times 1 is itself, anything divided by 1 is itself, so we simply have 5x minus 50. And on the right side, we have y times 0, which is 0. All right, so we have now rewritten our second equation. Equation 2 has been rewritten. And we still have equation 1. Let's just copy it down here so that they can be side by side, one atop the other. Okay, and now we have to make our decision. Substitution or elimination? Well, the first thing that we would normally do here is look for x's or y's with a coefficient of 1 or negative 1. And there are a lot of terms to look at, so let's do that carefully. There's a y with nothing else, no x's or exponents, but the coefficient is 49. Same with this one. There's an x, but the coefficient is positive 5. There's an x, but the coefficient is negative 5. It doesn't appear that substitution is going to be the right answer for this problem. So that means that I need to find a way to eliminate. And by eliminating, my hope is to multiply one or both equations by some number on both sides to create opposites. Well, the first thing I notice is that my y squareds are identical here and here, and my y terms are both 49y here and here. So if I just multiply one of these equations by negative 1, that will create opposites for all of the y terms, and then when I add the two equations together, that's going to help me eliminate y. So I'm going to multiply equation 2 again. This time I'm going to multiply it by the number negative 1. Let's get this out of the way here. Okay, so distributing this negative is going to change all of the signs on the left side. So I'll get negative y squared minus 49y minus 5x minus 50. Plus 50. Let me just check that, make sure I said that correctly. Minus y squared minus 49y minus 5x plus 50 equals 0. And there we go. We now have our new version of our system with our opposites in it. And now that we have those opposites, this gives us an opportunity to add the two equations together. All right, adding our two equations together, the y squared minus y squared is 0. The plus 49y minus 49y is 0. Then I have plus x squared minus 5x minus another 5x makes minus 10x. Minus 50 plus 50, that cancels to 0. And so my new equation has no y's in it and a bunch of zeros. In fact, if we were to write that equation in a more simplified form, the only parts of it that I would need would be x squared minus 10x equals 0. And that's a fairly easy equation to solve. I can solve that by factoring. factor out an x, so I get x times x minus 10 equals 0. By the zero product property, x equals 0 or x minus 10 equals 0. So I get two solutions, x equals 0, x equals 10. But remember, this is only half of the problem, and it's possible that either one of those potential values could be extraneous and therefore not the correct answer to this problem. So I do need to find a way to plug back in and come up with a value for the y's that go with each x. All right, so let's do that. We need to pick an equation to plug back into. Okay, when you plug back into an equation, typically you want to plug back into the simplest equation. So let's plug into the one that doesn't have a fraction. And so we're going to plug into equation 1. So we get y squared plus 49y plus x squared minus 5x minus 50 equals 0. And what we want to know is, what would happen if x was 0? So if x equals 0, then we would get y squared plus 49y plus 0 squared minus 5 times 0 minus 50 equals 0. So we get y squared plus 49y plus 0 doesn't change anything, minus 0 doesn't change anything, minus 50 equals 0. And I can solve this by factoring. I notice that my variable squared term has a coefficient of 1, so this is a simple trinomial. My terms are already in descending order, there's no GCF, so I just need two numbers that multiply to make negative 50, but add to make positive 49. Those numbers would be positive 50 and negative 1. Put a y in front of each one and you've got your factors. I'm going to move these down here. Clear just a little bit of space. Okay, so y plus 50, y minus 1 equals 0. By the zero product property, we get y plus 50 equals 0, or y minus 1 equals 0. So y equals negative 50, or y equals 1. Now, this is a very interesting result because for this one value of x, we got two values of y, which means that this value of x is actually going to generate 2 points in our answer. 0, negative 50, and 0, 1. So one value of x spawned 2 ordered pair solutions, potential ordered pair solutions. We do, of course, have to check both of those to make sure that they really are the right answer. Okay, so now we have to check the other value, right, which was 10. So this problem is a little bit on the longer side. All right, here we go. Now replacing all the x's with 10. Again, I'm choosing equation 1 to plug into. So I get y squared plus 49 times y plus 10 squared minus 5 times 10 minus 50 equals 0. Y squared plus 49y. 10 squared is 100. 5 times 10 is 50. And all of these numbers are going to cancel. 100 minus 50 leaves 0. So I get y squared plus 49y equals 0. We will also solve this by factoring, but it'll be easier. The GCF is y, so we get y times y plus 49 equals 0. I will repeat that algebra at the top of the next column. Okay, so y times y plus 49 equals 0. By the zero product property, I get y equals 0, or y plus 49 equals 0. And this is already solved. This gives me y equals negative 49. And so now, again, I get two values of y for a single value of x. We were checking if x was equal to 10 this time. So we get 10 comma 0 and 10 comma negative 49. All right, so this one value of x gave us two ordered pairs. And I erased this, and I shouldn't have, because now I'm going to have to see if I can remember what those were. Let's see, when x was 0, those were gone, and so we had y plus 50, so negative 50, and y minus 1, so 1 was the other solution. Okay, great. So we've got 4 potential solutions. We don't know if they are right or wrong. The only way we'll discover if they are right or wrong is by checking them, and we will check all 4 points in both equations in our next video, our longest check sequence so far.